Hello everyone, welcome back to another MCR3U1 video, and today we'll be starting chapter 5 regarding trigonometric ratios. Again, in this video we will cover the theory for sections 5.1 and 5.2, that being trigonometric ratios of acute angle, which is 5.1, and evaluating trigonometric ratios for special angles, which is section 5.2. In a later video, we will do some examples using what we learned in this video. This is the chapter outline we will be following for the rest of this chapter, and you can find extra practice questions on the topics covered today on pages 280 to 282 for section 5.1 and 286 to 288 for section 5.2. So let's get started. Here's the success criteria for this lesson, so let's just go over it real quick. Firstly, we want to learn the three primary trigonometric ratios and how to use them, and there's actually a really clever acronym that we can use to remember these ratios called SOHCAHTOA, which I'll go over in the later slides. Then we want to learn the three reciprocal trigonometric ratios and how to use them. Next, we want to learn the ranges of each of the six ratios, meaning what values they span. And lastly, we want to learn about the two special triangles and be able to use them to solve problems. First, let's go over the three primary trigonometric ratios we need to learn. So here we have a right angle triangle with sides A, B, and C, and with angles C, which is 90 degrees because of the right angle triangle, B, which is angle theta, which is the angle we're going to be using, and then we have angle A, which is just the last angle. Okay. So the three ratios that we want to know are sine, cosine, and tangent. So let's go over all of them. Let's go over sine first. If we are using the angle theta, right, which is the angle at vertex B, the sine ratio of that angle will be the side opposite to that angle over the hypotenuse, right? So the side opposite to angle theta is going to be B, right, opposite to angle theta, and the hypotenuse of the triangle is going to be C, right, opposite to the 90-degree angle. And so since sine of theta is going to be the ratio of the side opposite to theta all over the hypotenuse, we're going to get B, which is the opposite, over C, which is the hypotenuse. Right? So that's our sine. Next, we have cosine. And again, if we take the cosine ratio of angle theta, the ratio will be the adjacent side this time to the angle over the hypotenuse of the triangle. So the adjacent side of angle theta is the side that touches angle theta, right? That is not the hypotenuse, because this side touches the angle theta, but it's not the hypotenuse, right? So our side A is going to be adjacent to angle theta, and so our cosine ratio of theta is going to be A, which is the adjacent side, over C, which is the hypotenuse, okay? So that's cos. And then lastly, we want to look at the primary trig ratio tangent. The tangent ratio over angle theta will be the opposite side of the angle over the adjacent side of the angle, right? So in this case, the opposite, again, to angle theta is B. The adjacent is A. So our tangent of theta, our ratio, is going to be opposite, which is B, over adjacent, which is A. Okay, so now we can learn about a very useful acronym that many use to remember what side goes on the denominator and what side goes on the numerator for each ratio, which is SOHCAHTOA, right? So we'll go over each one. So, or SO, stands for sine, opposite, and hypotenuse, which tells us that for the sine ratio, first comes the opposite side of the angle, and then comes the hypotenuse, right? So the first letter of the acronym is going to be our ratio. The second letter is going to be the numerator of the ratio, and the third letter is going to be the denominator of the ratio, right? So we have sine, the numerator is going to be opposite to the angle, and the denominator is going to be hypotenuse, right? So in this case, if we have sine of theta, What's our opposite? It's b, so that's going to be our numerator. What's our hypotenuse? C, so that's going to be our denominator. And that's basically how it works. So if we move on to Ka, which is quite the same, Ka just stands for cosine, adjacent, and hypotenuse. So again, the first letter is our ratio, which is cosine. The second letter is our numerator, which is adjacent. And our third letter is our denominator, which is hypotenuse, right? So in our case, if we have angle theta, we're going to have cosine of theta. It's going to give us adjacent, which is A, over hypotenuse, which is C. And that's our ratio. And finally, we have TOA, which stands for tangent, opposite, and adjacent. So tangent, opposite, and adjacent. So again, we're going to have, for the primary trig ratio tangent, opposite over adjacent, right? Numerator and denominator. And that's a really nice way to remember all the trig ratios and what goes in the numerator and the denominator, and it just makes it easy for us to remember, right? Now let's look at the three reciprocal trigonometric ratios, which are defined as 1 divided by each primary trigonometric ratio, and we can see this below. Again, we have the same triangle, right? We have ABC as the side lengths and ABC as the angles as well. Our first reciprocal ratio is cosecant, which is 1 over sine, right? So we take sine theta and we do 1 over sine theta, and that gives us cosecant theta. This means that since sine was opposite over hypotenuse before, right? If we remember, sine theta was opposite over hypotenuse, right? Now we are taking the reciprocal of the ratio and turning it into hypotenuse over opposite. So if we do 1 over sine, right, we have to do 1 over opposite over hypotenuse, which is the same thing as saying 1 times hypotenuse over opposite, which will give us hypotenuse over opposite, right, which is what we have here. And that's our cosecant ratio, the hypotenuse of the triangle over the opposite side from the angle theta, right? So in this case it's B. So we have hypotenuse of C, right? And then we have the opposite side to angle theta, which is B, and that's our cosecant of theta. Okay. Then we have secant, and the ratio secant, which is represented by SEC, theta, is 1 over cosine. So since before we have cosine theta as adjacent over hypotenuse, if we remember from the last slide, cos theta equals adjacent over hypotenuse. Now we are taking the reciprocal of that and we are turning it into hypotenuse over adjacent, right? So now secant theta is going to be the reciprocal of this, so it's going to be hypotenuse over adjacent, which is what we have down here, hypotenuse over adjacent. And in this particular triangle, again, hypotenuse is C, and the adjacent side to angle theta, remember, is the side that's touching angle theta, but obviously not the hypotenuse, is this side, side A. So we're going to have secant theta is equal to C over A. That's our ratio. Okay? Let me erase this. Lastly, we have cotangent, which is the reciprocal ratio of tangent. So cotangent theta will equal 1 over tangent theta. And if we remember, tangent of theta is opposite over adjacent. So we're just going to take the reciprocal of that and get adjacent over opposite. And again, adjacent to theta, we have A, and opposite to theta, we have B. So our cotangent of theta is going to be A over B. So in summary, the reciprocal ratios are exactly what they're called. You take the primary ratio and you do 1 over the primary ratio, which is just taking the reciprocal. And an easy way to remember the names is that they're basically opposites. So cosecant is for sine, which starts with an S, and secant is for cosine, which starts with a C, right? Cosecant is the reciprocal of sine, secant is the reciprocal of cosine. So the way I like to remember it it's just opposite, right? So if I see cosecant starts with a C, so it must be the reciprocal of sine. Secant starts with an S, so it must be the reciprocal of cosine, and cotangent, it has tangent in the name, right? So we're gonna have the reciprocal of the tangent, right? Okay, let's move on. Quickly go over the ranges for all the ratios. So the sine and cosine ranges are going to be less than or equal to 1. And then since cosecant and secant are the reciprocal of sine, right? So if sine theta is going to be less than or equal to 1, right? If we take the reciprocal of that, right? If this is a very small number or 1, we're going to get, in this case, cosecant of theta is greater or equal to 1, right? Because if we have, for example, 0.1 and we have that in the denominator, it's going to make the whole number bigger, right? So cosecant and secant are going to be greater or equal to 1, which is exactly opposite of sine and cosine, okay? And lastly, we have cotangent, next we have tangent, right? Which can be any value, less than, equal to, or greater than 1. And cotangent, since it's the reciprocal, right, it will be the exact same, because if we have tan theta, if tan theta is a very small number and you take the reciprocal, it's going to make a very big number, and this one's small, right? If we have a large number, greater than 1, large, right? The reciprocal of this is going to be a small number, right? Or if it's exactly 1, we're just going to get 1, right? So it's exactly the opposite for cotangent, so it's going to be the same range. And here, on the right, we have the exact same ranges for each ratio, but just in a table style, just in case this is more useful for some of you. So again, sine is less than or equal to 1, cosine less than or equal to 1, cosecant greater or equal to 1, secant greater or equal to 1, tangent less than, equal to, or greater than 1, cotangent, same thing, less than, equal to, or greater than 1. Now let's move on to special triangles. There are 2 special triangles that we want to learn and memorize if possible, because they will help us tremendously while solving problems. The first right triangle has, of course, a 90-degree angle, and it has 2 45-degree angles at the other 2 vertices, right? Opposite to these 45-degree angles, the side lengths are going to be 1 for the special triangle, and our hypotenuse is going to be square root 2, or opposite to the 90-degree angle. Okay, that's our first special triangle. Our second special triangle has a 90-degree angle, again, of course, which looks a little bit messed up here, but it's like that. A 90-degree angle, a 30-degree angle, and a 60-degree angle. Opposite to the 30-degree, we have a 1 as a side length. Opposite to the 60, we have a square root 3. And as a hypotenuse, we have 2, right? And I want to explain something real quick. These special triangles, it doesn't mean that the side lengths are always going to be 1 or square root 2. The angles will always be the same for these special triangles. But as we're going to see right now when I explain the ratios, these side lengths could be really anything. They just must be equal for this triangle. And these 2 side lengths just have to have the same ratio, but they don't have to be square root 3 or 1. But when you take one of the primary ratios or reciprocal ratios, they must simplify to the same ratio. For example, if you take the tan of 30 here and you do opposite over adjacent, right? If this is like 40 and this is like some other big number, if you take 40 over that big number, it must simplify to 1 over square root 3, right? So the side lengths are not particularly just 1 square root 3, 2. They can be anything, but the ratios are what stays the same and constant, okay? So these are the different ratios for each triangle. So if we're working with the angle 30 degrees, sine of 30 is going to give us 1 over 2, because again, its sine is opposite. over hypotenuse, so it's going to give us 1 over 2. And again, if this is what I'm saying, if this side was 2 and the hypotenuse was 4 and this was some other number, sine of 30 would still give us 1 over 2, right? But it's just the ratios that stay the same, not particularly the lengths of the sides. So moving on, we have cos of 30 is going to give us square root 3 over 2 because cos is adjacent over hypotenuse, so it's going to give us square root 3 over 2. And lastly, tangent of 30 is going to be opposite over adjacent, which is going to give us 1 over square root 3, but we don't want square roots in the denominator, so we're just going to multiply by square root 3 over square root 3, which is going to give us square root 3 on the top, and square root 3 times square root 3 is going to give us 3 on the bottom. Okay, that's how we get this. Moving on, we have angle 45 degrees from this special triangle. So our sine of 45 is going to be opposite over hypotenuse, or you could take this one as well, opposite over hypotenuse. It's going to give us 1 over square root 2. But again, we don't want a square root in the denominator, so we're just going to multiply by square root 2 over square root 2, which is going to give us square root 2 over 2, right? And that's how we get this. Cos of 45 is going to give us the exact same thing because the adjacent and the opposite sides are both going to be a 1 or not a 1, but the ratio is going to stay the same, and it's just going to be 1 over square root 2 if you choose sine or cosine. Now for tan of 45, we have to do, again, opposite over adjacent, which is going to give us 1 over 1, which is going to give us 1, or if the side lengths are, for example, not 1, and they're, for example, 45 over 45, right? Tangent of this 45-degree angle is going to be 45 over 45, which will get us 1, the same ratio, right? The lengths of the sides just have to be equal. Finally, we have the 60-degree angle. So for sine of 60, again, we do opposite over hypotenuse, square root 3 over 2. For cos of 60, we do adjacent over hypotenuse, so 1 over 2, which is what we have here. And for tan of 60, we have opposite over adjacent. So opposite is going to be square root 3, adjacent is going to be 1. So we're just going to have square root 3 over 1, which is just square root 3. And this is all we need to remember. We need to memorize, or we don't need to memorize, but it's good to memorize. You could have kind of a cheat sheet beside you while you're solving problems, but it's good to memorize, for example, if you're doing a test, or just in general, right? Because these special triangles really do help you on a lot of different problems. Okay, in this slide, I just want to go over some facts to remember about special triangles. First fact, since tan of 45 is 1, because remember, we have a 45 and a 45 degrees. We have a 1 and a 1 and a 2, or square root 2, sorry. So tan of 45 degrees is going to be opposite adjacent over adjacent, so it's going to give us 1, right? So since tan of 45 is going to give us 1, angles between 0 and 45 degrees have a tangent ratio of less than 1. And so angles between 45 and 90 degrees are going to have tangent ratios of greater than 1. Right? And this makes sense because if you have 45 and you have, let's say, a 1 over 1, if you decrease this angle, so let's say if you make it this kind of like flatter, so this angle is less than 45, this side length is going to be less than 1, and this side length is going to be greater than 1. So if you get a number that's less than 1 over greater than 1, it's going to give you a small number, right? And so the tangent ratio is going to be less than 1, right? Because our kind of standard is 1 over 1, but if you decrease this side and increase this side, you're going to get a ratio less than 1, right? It makes sense. And for angle is greater than 45, we can do the same test. So we have our special triangle here, square root of 45, and our side lengths of 1 and 1. So if we increase that angle, so this angle now is greater than 45, this side now is going to be greater than 1, and this side is going to be less than 1, right? So if we take the tan of this angle, we're going to do opposite over adjacent, so we're going to have a number greater than 1 over a number less than 1, which will get us a number that is greater than 1. Right? Makes sense? It's going to get us a bigger number than 1. Right? That's all we need to remember. Okay, so on to fact number 2. If a right triangle has one side that is half the length of the hypotenuse, then the angle opposite to that side will be 30 degrees. So to prove this, to see this, we can draw out our other special triangle, which is going to be 60 degrees, 30 degrees, and a 90 here. And opposite to the 30, we have a 1. Opposite to the 60, we have a 3, a square root of 3, and hypotenuse, we have 2. So as you can see, the angle, the side opposite to 30, it's going to be 1, and the hypotenuse is 2, and 1 is half of 2. So for every triangle that has an angle of 30, right? The side opposite to that angle, if one of the sides in the triangle, any side, it could be this side as well, is half the hypotenuse, then the angle opposite to that side will be 30. Sorry, it's not the angle. If you see an angle that is 30, the opposite side does not have to be half the hypotenuse. But if the side here is half the hypotenuse, then the angle opposite to that side is going to be 30. Okay? And lastly, if a right triangle has two equal sides, then the angle opposite to those sides is always 45 degrees, right? So like I said before, if we have a right triangle and these sides are the same, then these angles are going to be 45 degrees. Pretty simple. Okay guys, thank you so much for watching the video, and in the next video we will go over some examples that use primary and reciprocal trigonometric ratios as well as special triangles.